Hello guys, welcome back to another video. Today we have yet another Gauss question here, and as always, let's first start by reading the question. So consider the following diagram. Three line segments PS, QT, and UR all intersect at X such that PX equals XS, QX is going to equal to XT, and UX is going to equal to XR. Every 12 minutes, bus A completes a trip from P to X to S to X to P, and every 20 minutes, bus B completes a trip from Q to X to T to X to Q. Every 28 minutes, bus C completes a trip from R to X to U to X to R. And at 1 p.m., buses A, B, and C depart from P, Q, and R respectively at the same time, each driving at a constant speed, and each turning around instantly at the end point of its route. Now, each bus runs until 11 p.m., and so at how many times between 5 p.m. and 10 p.m. will two or more buses arrive at X at the same time? Now, let's first look at where A, B, and C all sort of start off from. So we know that A starts off at P, so I'll just write A here to show that A is going to start from here. B departs from Q, I'm pretty sure, let me double check. Yes, B departs from Q, so I write B here, and C departs from R, so right here. Now, as you can see here, C takes 28 minutes, B takes 20 minutes, and A takes 12 minutes. This means for these sections, so there's one section here, one section here, then I have to go back on this one, and they have to go back. So for each sort of section here, it takes 3 minutes for bus A. Now this means that bus A will stop at, considering that it starts at 1 p.m., this means that bus A, so it's a big A here, you can see that X is going to stop at 103, and that's at 6, so for example, we move down here, this takes 3 seconds, and since we started at 1 p.m., we add 3, so this is 103, 106, back to 109, so we write it down. And then after that, you start to see a pattern where there's plus 6 in between, and you can look at this again. So 109, 1012, 1015, and we can only see a pattern with A, where the first stop at X is going to be at 103, and each stop after that is going to have an increase of 6. Now this means that for our current range, so from 5 to 10, X is going to stop at 503, since the interval that we're counting, which is 6, is divisible, is 6 is a divisor of 60, so this means if we just keep on counting, it's going to be the same for every hour, so that means X is going to stop at 503, 509, 5015, and so on. Now let's look at bus B. Now bus B is basically the same thing, but instead of 12 minutes, it's going to be 20 minutes. This means that each trip is going to be 5 minutes. So following logic from before, it's going to be here, it's going to be 105, 1010, 1015, 1020, so let's talk about 105, 1015, 1025, and so on. Which means that it's going to be starting at 105, and it's going to be an interval of 10 minutes per sort of interval between the time that it goes back to X. Now, instead of just writing this one, I'll just write it immediately. So we know that X is going to stop for bus B at 505, 515, 525, and so on. Now, let's first start off by the intersections of A and B. So I'll just write it like this, AB. Now, we see that the interval for A is going to be 6, and the interval for B is going to be 10. Now this means that the LCM between 6 and 10, which is 30, which means that the interval for AB should be around 30 minutes. And we see that the first instance of this happening at our 5 to 10 p.m. Sort of time zone area for duration is 5:15. This means that the first stop where both of these intersect, so A and B, they both arrive at X, is going to be first at 5:15, 5:45, 6:15, and so on. So it's going to be the 15th or 45-minute mark of each hour until 10 p.m. Now this means that there should be 10 in total, as it's 5 times 2. Because there's 5 hours, so 5, 6, 7, 8, 9, and in each hour there's going to be 2 possibilities. So that means there's going to be 10 in total. So now let's go backtrack. Now let's look at bus C's intervals. Now bus C is a little bit different, as it takes 28 minutes for a whole round trip. This means that each length should only take 7 minutes. So for example, 1 p.m. 1 p.m., 1:07 p.m., 1:14 p.m., 1:14 p.m., 1:21 p.m. So it's going to be similar to before, where the first x value is going to be 1:07, but then it's going to be adding by 14 each time. And this obviously starts to make a problem. As before, I can easily tell when the first value past 5 p.m. was where the bus A arrives at x. But since 14 is not a divisor of 60, we can't really do that here, which is why we have to use different means. Now we can see that 14, which is the interval, times 17 is going to be equal to 238. And if you didn't know, 238 is just 4 hours minus 2 minutes. So as you can see here, this means that we can sort of just use this to realize that, let's look at 1:07. So 1:07 is this, and after that we just add 4 hours into it, and also just remove 2 minutes from the time. And this is going to result into, so I'll just add plus symbol, so you can see, this results into our bus of bus C arriving at 5:05 p.m. So now that we have this now, we can see that x is going to arrive at 5:05 p.m., 5:19, and so on, like before. So I just did all of this so we can see what's the first time after 5 p.m. that bus C arrives at x. Now we can look at the other relations. So let's first start off with AC. Now AC is going to be pretty simple. As you can see here, the interval between the x values for C is going to be 14, and for A it is 6. And so the least common multiple of 6 and 14 is going to be 42. This means that the interval between A and C is going to be 42 per x value. This means that for this thing, this means that for AC, the relation, we can see that we can both arrive at x at 5:33, 6:15, 6:57, sorry, 7:39, 8:21, 9:03, and 9:45, for a total of 7 different possibilities. And now we'll do the same exact thing, but for BC. Now, BC, we can see that the interval for B is going to be 10, and the interval for C is going to be 14. So the least common multiple between 10 and 14 is going to be 70. This means that our values of x is going to be at the first one, which is going to be 5:05, 6:15, 7:25, 8:35, 9:45, which is going to be 5 values. This means that in total we should have 10 plus 7 plus 5 values, which is 22. But there is going to be repeats here that we need to sort of take care of. Now, going back to our AD relationship, we can see that it's going to be on every 15th or 45th of an hour. So 5:15, 5:45, 6:15, 6:45, and so on. So now let's look at AC and BC, which are written out completely. We can see that there are 2 values for each of these that overlap with AB's relationship. So 6:15 here in 9:45, and 6:15 and 9:45. So in other words, we've triple counted 6:15 and 9:45. And that's obviously something that we do not want here. So we'll have to minus 2 times 2. So it'd be 10 plus 7 plus 5 minus 2 times 2. Why? Well, because we're overcounting 2 numbers in the APO. Actually, no, sorry. We're triple counting these 2 numbers. So that means it's going to be minus 2 times 2, which is going to be equal to 18. This means that the answer to this problem should be A, for 18. Thank you guys for watching. If you have any other way to solve the problem, please let me know down below in the comments, and thank you guys for listening. Bye.